Good morning, guys. So this morning I have a board that was sent to us by a customer, and it's a 13-inch. The model number or the board number is 820. Where is it at? 820-2936. And so this board in particular, he said, will not see the hard drive because of a possible power surge. So I'm going to try to lead you through how to diagnose this. I'm going to try to do that more of the board repairs. I'll walk through of how to diagnose it, pretend like this is my first time doing it, so hopefully it can help you guys out as well. So the first thing that's important to have when you're going to be working on boards is to have diagnosis or diagnosis parts. Parts to use in your diagnosis. You need a known good MagSafe, you need a known good fan, and you need something like, for this in particular with the hard drive not working, you need a hard drive cable that is in good functioning order that that works, so that you can test it and narrow down what the possibilities might be to fix it. And you need known good RAM and a hard drive, of course. With this particular issue, what we're going to do is we're going to first power up the board. And this one does not have a heatsink, so I'm going to have to get a heatsink for this board. You don't want to leave the board on too long without a heatsink because it can damage your CPU. So let me get a heatsink for this, and I'll be right back. Got a heatsink here, and we're going to put this on the board real quick. And I am going to apply some thermal paste to the board, because what's the point of putting a heatsink on without thermal paste? Apply the thermal paste, put the heatsink on, and put the screws back in. And this is going to keep that board from getting too hot while we're testing it. There we go. Alright, now we have the heatsink on, we have our MagSafe in. We're going to plug in the RAM, plug in the fan, and I have a test display as well, which is important to have. Okay, and we're going to plug in the hard drive cable. So now we're going to plug in this hard drive, and he said that the hard drive was getting, it will not see the hard drive, is what he wrote down. So one thing to do when you're testing your board for a hard drive error like this is having, he says it's not seeing the hard drive. So one of two things: it's either not getting power, the hard drive is not getting power, or two, it's not transferring data. Because I've seen before where the hard drive will spin up, but it won't transfer any data. You're still not able to see the hard drive. This one may not have an issue with transferring data. It may not be powering up the hard drive, so it may not be spinning the drive. So when you're testing an issue like this, it's important to have an actual hard drive instead of an SSD, because an SSD has no moving parts. You won't be able to tell if it's powering up or not quickly without using a multimeter. So what we're going to do now, I have everything plugged in. I'm going to plug in the power adapter here. See, we got the fan spin, we have our sleep light came on, and we have a display. But the hard drive itself is not spinning at all. So we have no power to the drive. So that's going to be the issue with this one. It could have been from a power surge. So what we're going to do now, since we know for sure that this is not getting any power, we're going to unplug it, and we're going to look at the Boardview and the schematics to see if we can figure out what might be the issue. So first off, let me show you the Boardview. Alright, so here we have the board view of this board, the 820-2936, and here's our hard drive connector. Okay, so you see here it says J4501. That's the part number for this connector. So it's really nice to be able to use the board view in connection with the schematics, because just looking at the schematics it's going to be difficult to figure out where the location of these parts are. So if you're just learning how to do this, it is a must to have the Boardview software and the schematics to work in connection. Now, I'm going to pretend like this is my first time on doing this, so we can walk through how to do this. See, so I've mentioned there J4501. So now we go to the schematics, bring the schematics up here. So here we have the schematics for this board, the 820-2936, and we're going to do a search, just a PDF search, J4501. And over here on the left side you see it brings up two locations. First one is this. This is going to be our system block diagram, which is kind of nice because it kind of shows how everything works with our PCH chip. What parts are connected to the PCH. And you can see there's a lot of different functions of it. The one function we're concerned with right now is the SATA. And here's the SATA connector, which is the J4501. Now on page 42, this goes into more detail about this connector. Here's our J4501 connector. When a part is critical, like it mentions here, that means it's critical for this machine to function. That has to be working, which, I mean, without that, you're not going to have a hard drive. So obviously it's going to be a critical part. Now, we know for sure that we have no power to the hard drive because it's not turning on. The hard drive is not spinning up at all. So right here is going to be our power in. The PP5V, when it says 5V, that's going to mean 5 volts. You have 5 volts going through this line. So then it goes through this part here, this fuse, and then it's going to go to through this rail, this line, and down to the connector, and that's connecting on pins 1, 3, 5, 7, 9, 11, and 13 of that. And I'll show you back over here at the board view again. The connector. So I mentioned it goes through 1, 3, 5, 7, 9, 11, and 13. So that's this whole first part here. And you can see I click on that and it lights up all 7 of those pads, because this is all the same circuit, all from the same power rail. So it's going to light up all those because all of those are getting that 5 volt power. As you see there, the PP5V. So that's going to be our power in. So what we're going to do is we're going to go back to the board here, and let's see if I can get a good view. I'm going to use the multimeter on voltage mode because we're going to be checking for power in that rail. And looking at the board view here, you see it's that top right. All 7 of those pads are going to be what we're going to be looking at. So I'll show you in the microscope view. So there's those pads. Let me get you in focus here. Alright, I've got the microscope lined up here with our connector, and I've got the multimeter here. So we're going to check the top right 7 pins, which we just need to check one of them because it should be giving power to every single one of those. They're all connected. You can see the pad there is all connected. So I'm going to touch that, and what are we getting? Ooh, about 2 volts, and it's jumping around. So something's not right on that power line. So now let's look back over to our schematic. So we have, this is what we were checking. We were checking on pin 1 actually, I believe. Let's look back at the board view. Yeah, we were checking on this pin right here, pin number 1, which is this pin right here, which all these are connected. So it's going up, and it's going to this this fuse here. Now let's check that fuse and see if we're getting power on both sides of that. Because that, like it says, critical there. This is a critical part. If this part isn't working, then it's not transferring the power through it. So let's look at L4500. So let's go back over to the board view, and we're going to do a search of L4500. Okay, so that's on the back side of the board. in that location there. So let's take a look at that. I'm going to go ahead and power this off. Let's take a look at that and see what we have. Now let's see if you can find it with me here. Oh. So you see what's wrong? What part looks bad? Get you in focus, okay. So here is our fuse, right here. And you can see, let me see if I can zoom in on that. So you can see on top right there looks like a piece of solder. So when something like this happens, and you can see around the discoloration around the outside of it on the board, looks like it's burned up really fast, and that you can actually see a crack in that part. So I bet when we take this off, it's going to come off in 2 parts. But that little piece of solder on top there shows that this is burned up really fast, and actually solder burned through it onto the chip. So what we're going to do is we're going to remove that chip. I guarantee you this is the whole problem. So we're going to use our hot air station and remove that part. Actually has solder on the outside of the chip too over here. Amazingly, it came off in one piece, but you can see how it has a crack right through it. Yeah. Let's look at the side of that. Oh, there it goes, it broke. So you can see where it burned up on the side there as well. Alright, so we're going to replace that. We're going to first put on some fresh solder. Turn on my filter. Okay. We're going to add a little flux to the area. And I have a scrap board I'm going to pull that fuse from. Apply a little more flux. I'm going to touch it with a soldering iron on each side. Make sure it's nice and connected. Okay. So now let's see what we get. And now we're going to plug in the fan. Plug in power. And we're going to touch that pin again and see what kind of power we get now. Ah, 5 volts. So that's what we're supposed to get. So I guarantee you that the hard drive is going to spin up now. So let's go ahead and turn it off and get it plugged back into our little diagnostic test bench. Got a hard drive here that has something on it that we can see if it's reading it okay. And this is the hard drive I have all of my ASD diagnostic tools on. I'm going to hold down the option key on the keyboard here and see if we get anything that shows up on the screen. Alright, there we go. You can see all the partitions that are showing up here. So the hard drive is spinning up and it is working. So we fixed that problem. Alright, so what I'm going to do now is just give you a short walkthrough of what if it wasn't just the power, what if it was your data signals that were not transferring. Let's look back at the schematics here. Alright, so here was our problem. The L4500, this fuse here, this was broken. So therefore your 5 volts wasn't getting transferred through and it wasn't powering up your hard drive. But what if the data signals weren't being transferred? Here's going to be your data signals. Now this is your out, this is your in, so you have data transferred out and in. And so what we could have narrowed down then is these resistors. When there's anything with an R on it like this, that means it's a resistor. And this is your capacitor. So we could have narrowed those down, tested those out to see if they were good. And then the next thing you see in line is this IC chip here, the L or the U4510. So let's search for that in the board view and see where that's at. L4510. Nope, did that wrong. U4510. Sorry about that. There it is. Alright, so it's this chip right here. And I'll show you that under the microscope. So this chip right here is that U4510. So that would have been the next chip we would have tried to see if maybe that's the reason it wouldn't be transferring data. And if that wasn't the problem, if that was actually working fine after we replaced it with another chip, what we would do then is look over here. Sorry, there you go. If it wasn't this chip here, we would look on over and see where these data signals are going to. So you can see here it's SATA, HDD, D2R, DRVR, out P. Alright, so that's just one of them. You have the P, N, then you have the N, and NP. So you have out and in. And then you would see where these signals are being carried out to. So right here it changes to this name, SATA, HDD, DR2, P, and N. These are going out. So what I would do in this situation, if it wasn't that IC chip that was bad, I would then copy this data line, do a search for it, and see where it shows up. So you see it shows up on page 16. Okay, so here we have your PCH chip. So this signal from the hard drive is carried out of the hard drive and into the PCH chip. So unfortunately, if your problem wasn't the IC chip or there any of those resistors or capacitors, you're looking at a bad PCH, which unfortunately is not fun. That's going to be your BGA chip located underneath this, and I'll show you that. I'll just take off this shield so you can see what it is. This is a BGA chip that would require a special machine like we did on the GPU replacement. It would require a machine like that that could pick up the chip and replace it. So you can see the chip looks like this. So unfortunately that would be a difficult repair, and a lot of people don't have the machinery required to replace those. So if it was something like that, you could send it to us and we do that kind of repair here. But anyways, I hope walking through this information kind of gives you an idea of how to diagnose it. Personally, I'm still learning things about doing board repair every day. There's always something new to learn. It's a lot of information in these schematics to learn. These boards are complex, so a lot of diagnosing, a lot of trying to figure out. And if you're new to this, just get into it. Just start studying the schematics. Try to see where it all connects. Where does this line lead? Why does it lead there? What does it do after that? And that's the one way that you can start learning how to do board repair yourself. And definitely get the Boardview software as well to go in connection, so that you can find the part on the schematic, then connect it to the board and try to figure out how it all works. It's a lot of fun. It's a lot of work. It does make your head hurt after a while, but it's definitely worth it, and it's fun to learn. So anyways, I hope this helps you out. Hope you learned something from this. So it's good news that we figured out that it was just that fuse. Very easy fix, and we can get this board cleaned up and wrapped up and sent back to the customer so we can have another happy customer. All right, hope you have a great day.